Welcome back to our YouTube channel. In our previous video, we discussed on the complex number, the forms it has, the algebraic form, the exponential form, as well as the polar form, as well as the various operations that can be operated or carried out on these complex numbers. In this module or video, we'll be discussing the Argand diagram, which is the graphical representation of these complex numbers and how exactly we can use that graphical representation to also carry out the basic operation of addition and subtraction of complex numbers. As always, don't forget to like, share, and subscribe our videos. Also, don't forget to turn on your notifications to our channel so that you would have first-hand information when we drop new content. So let's begin. So for this diagram, the Argand diagram, we have picked two complex numbers, Z1 3 plus 4i and Z2 minus 2 minus 2i, and we would attempt to plot this on the Argand diagram. Now we have chosen a graph with scales 1 centimeter to 1 unit on both the x and y axis. The x axis will represent the real part, and then the y axis will represent the imaginary part. Do not forget, when you have when you have a complex number written, the real part and the imaginary part come together to formulate what we call a coordinate point, right? So the x1 represents the real part and then the y1 represents the imaginary part. So you have what you need to plot thus on the graph, right? So when the graph is representing complex numbers, that is when we call it the Argand diagram. So for Z1, right, on the x-axis, which is on the real part, we have the value of 3. So that's 1, 2, 3. We have the value of 3. And then on the imaginary part, we have the value of 4. 1, 2, 3, 4. So we proceed to, of course, formulate and draw this on our diagram as much as we can. So we have just stretch this upwards a bit and then connect this to it. So joining this to the origin, this line represents Z1, that is 3, 4. So this line represents the complex number Z1. That is how we have made the simple plot of this diagram. Now for Z2, we have minus 2 minus 2i. So on the real part, we have minus 2, that's minus 1 minus 2. And on the imaginary part, we have minus 1 minus 2 as well. So we'll go ahead to plot that. And here we go. So this would be the line Z2 minus 2 minus 2. So these two lines represent the two complex numbers as we have them. Now we can now use this. We have plot them, we have put them on the plot, which is the Argand diagram. We can now use that to carry out basic operations of addition and subtraction. For instance, if we were to carry out the operation of addition for Z1 plus Z2, if we just have that on the top here, Z1 plus Z2, remember the addition is done partwise, so real part adds to the real part. So you have 3 plus minus 2, then plus I, the imaginaries also had 4 plus minus 2. And then the final result would be 1 plus 2i. So now, if this is our final result, let us now see, can we utilize the diagram to also generate this addition? Now, in order to do that, we will carry out the process of overlaying the complex numbers or the lines representing the complex numbers over each other. For instance, just as we have that Z1, which is 3 plus 4i, is represented here. And then Z2, which is minus 2 minus 2i, is also represented here. To carry out the addition of Z1 plus Z2, it suffices for us to take from the origin to Z1 and then take from Z1 to Z2. Now, how do we do that? Let us take a pencil so that the lines are separate from each other. Now, in the case of Z1, remember it goes 3 plus 4i, so it goes from 0, 0 to 3, 4. Now, in the case of Z2 now, Z2 is normally supposed to go from 0, 0 to minus 2, minus 2. It therefore now suffices that the point 3, 4 will now be the new origin that will precede Z2. Now, how would we do that? Z1 has been constructed here. Now, at this point, let us overlay this as the new origin. Now, if this is the new origin, that's 0, 0, if we were to plot minus 2 and minus 2 from there, it means that this would now be the new 0 here. And then, if this is the new 0 portion on this part, and this is also the new 0 portion on the y-axis, it therefore means that for minus 2 on the real part, on the x-axis, this would be minus 1, and then this would be minus 2. And then on the y-axis, this would be minus 1, and then this would be new minus 2, if this becomes our new point of origin. If that's the case, if we connect these two portions, we'll now have, and then connect it here, and then the overlaid Z2 will now go from here to here. This endpoint that we have here is in fact the point Z1 plus Z2. Z1 went from the origin to 3, 4, and then Z2 continued from 3, 4 as the new origin to minus 2, minus 2 on the new graph. This connection here, when overlaid like that, so Z1 plus Z2, this point here, when read on the real graph, will now give us the value of the addition. Now let us see if it tallies. On the real graph, where this is the origin 0, 0, this is point 1, right? And then this is 1, 2. This is point 2, which means that this graph here points toward 1, 2. And what do you notice? 1, 2 here is the same as 1 plus 2i, which is what we got on the basic addition. So what does that mean? In order to add, we just simply plot the first Argand diagram of the complex number, then overlay on it or continue from its endpoint the second complex number. The endpoint of that joined line would give us the addition. Now, it doesn't always have to be Z1 plus Z2. Remember, commutativity holds as far as complex numbers are concerned, which means that Z1 plus Z2 is also the same thing as Z2 plus Z1, which means if you were to plot Z2 first and then overlay Z1 on Z2, you would still get the same thing. What does that mean? It means that if I had taken this as my 0, 0, that's as my origin, this would have been the new 0 here, this would have been the new 0 here. Then in order to plot Z1 on it, don't forget Z1 is 3, 4, it should have been on the x-axis 1, 2, 3, and then on the y-axis it would have been 4. So that would have been 1, 2, 3, 4. So you see that 3 to 4, I would still have the same connection, right? Because this is 1, 2, 3, 4 on the y-axis, and then on the x-axis this is 1, 2, 3. So you see that whether I overlay it from Z1 to Z2, I go from Z2 to Z1, I will still come across the same additive space. That tells us that commutativity holds. Now, just as we have carried out the concept of addition, we can also carry out the concept of subtraction. How? Do not forget that when we take Z1 minus Z2, it is the same thing as adding Z1 to the negative of Z2, which means that in order to solve correctly, all we just need to do is find out what the negative of Z2 is on the graph and then add it to Z1. Now, how do we do that? Don't forget Z2 is minus 2 minus 2i. So if we were to take the negative of Z2, what would we have? The negative of Z2 would be the negative of minus 2 minus 2i, which would simply be 2 plus 2i. 2 plus 2i. That would be the value of minus Z2. And if we were to plot that, don't forget, this is 1, 2, this is 1, 2. So it means that originally, if we go up from here, and then connect here, and put a point here, this point here would represent minus Z2, which is what? 2, 2. Minus Z2. Notice that when you take minus Z2 and Z2, it formulates for you a straight line because they are opposites of each other, right? They have the same value representation different sign. So they would always form a straight line when overlaid on the Argand diagram, right? Z2 minus Z2 formulate a straight line. Now, in order to find Z1 minus Z2, it suffices to take Z1 plus minus Z2. Now, we have said minus Z2 is 2, 2. So it means that on Z1, if we were to overlay 2, 2 on it, taking this as the origin, what would we have? This would be 1, 2, and then this would be 1, 2. So what does that mean? It means that if we were to stretch these lines together, what would we have? And then on this side, here we go. And then connecting it directly on Z1. So from the origin to Z1 and then from Z1 to minus Z2, this point here will now be Z1 minus Z2. Z1 minus Z2. And if we look at the value on the graph itself, this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6. So this tallies to 5, 6, or to the complex number 5 plus 6i. Now, if we were to check if that is exactly what we would have, look at this. Z1 is going to be 3 plus 4i minus 2 minus 2i. So that will be 3 minus 2 plus I 4 minus 2. So if we simplify this, what would we have? We would have 3 plus 2, that is 5, plus 4 plus 2, that is 6i. So you see, z minus z2 is indeed 5 plus 6i, which is the same thing we obtained on the Argand diagram. So when we talk about the Argand diagram, we simply talk about the representation of a complex number on a graph, right? With this representation, we can carry out the process of addition, and we can also carry out the process of subtraction. Now that we have looked at how the Argand diagram is utilized, in our next video, we will discuss on the concept of the modulus and the argument, as well as how to utilize the modulus and argument in converting algebraic forms of complex numbers into the polar form as well as the exponential form. So if you have made it this far, also remember to like, share, and subscribe to this YouTube channel. Turn on the notification so that you are also informed of when we have new posts up for you, as well as make sure to watch the next video. Thank you.